let's do 4.2, binomial distributions. Okay, so binomial experiment is going to satisfy these conditions. The experiment has a fixed number of trials. You'll see what that means in just a minute, where each trial is independent of the other trials. There are only two possible outcomes. There's either a success or a failure. Now, success might not look like what we think of success, but it's what the experiment is looking for as a success or a failure. The probability of success is the same for every single trial, and the random variable x counts the number of successful trials. So n is going to be the number of trials, p is going to be the probability of success, q is going to be the probability of failure, and that ends up being that because there's only the two, q is going to equal 1 minus p. And then finally, x is the random variable, and that's the count of the number of successes. All right, so we have a binomial experiment. We are going to, so one experiment would be that we would talk to 1,012 people about identity theft, and a success would be a person who's a victim of identity theft. Okay, now that doesn't look like success to us, but that's what the survey is looking at for, so they're calling that a success. Another type would be picking a card from a standard deck of cards. If you pick a card and note whether it's a club or not a club, and then put the card back in and do it again, this would be a binomial experiment. So the probability would always be 1/4 because there's the club cards make up 1/4 of the deck, and the Q would be 1 minus 1/4 or 3/4. And so that would be the same every single time because we're replacing the card. If we weren't replacing the card, that would be a whole different issue. Okay, so let's look at something and see if they are binomial experiments or not. So with the first one, it says a certain surgical procedure has an 85% chance of success. A doctor performs the procedure on 8 patients. The random variable represents the number of successful surgeries. Okay, so since it's an 85% chance of success, that means that P would be 0.85, just changing the percent to a decimal. Q would be 1 minus 0.85, and so that would give me 0.15. N would be 8 because we performed the procedure on N patients. And then the random variable would depend. If we want 4 successes, if we want 6 successes, that would be the random variable. So this one is a binomial experiment. That one works. The second one is a jar contains 5 red marbles, 9 blue marbles, and 6 green marbles. You randomly select 3 marbles from the jar without replacement. Okay, as soon as you see that, we don't have to go any further. Without replacement means that the probability is not going to be the same every time, right? If we use conditional probability, like we learned in chapter 3, once you took a marble out and didn't put it back, now your probability is going to change. It's not going to stay the same every time. And so this is not a binomial distribution. All right, so this is just an explanation again of the 2 problems we just looked at without my writing all over it. So that gives you an opportunity to read the explanation. All right, so again, please don't panic when you see this. We are not going to be doing this, so do not hit help me solve this. You definitely want to go to the lecture videos, lecture notes, email me, but you want to use StatCrunch, and don't use this crazy formula for the binomial probability. All right, so this problem, I really just want you to get it set up. I'm going to show you how to use StatCrunch in a few minutes. So we have a rotator cuff surgery has a 90% chance of success. So that means that P is 0.90, Q is 1 minus P, so Q is 0.10. The surgery is performed on 3 patients. So that's N equals 3. And we want to find the probability of the surgery being successful on exactly 2 patients. And so X would be 2. I went ahead and showed you how to do this one by hand, but we're going to use StatCrunch. Just give me a few minutes and I'll show you the StatCrunch screens. All right, so here's another binomial probability. The survey found that 26% of US adults believe there is no difference between secured and unsecured wireless networks. A secured network uses barriers such as firewalls and passwords to protect information. An unsecured network does not. You randomly select 100 adults. What is the probability that exactly 35 adults believe there is no difference between secured and unsecured networks? So I did show you how to do it by hand, but this one we are going to do on StatCrunch on the next page. But we have to grab everything that we need. So first they told me that 26% of US adults believe there is no difference. Now I know that doesn't sound like a success, but we're going to, for our study, that's a success. So P is equal to 0.26. That means that Q is equal to 0.74, 1 minus 0.26. We talked to 100 adults, so N is equal to 100. And we want the probability that exactly 35 adults. So we want X to equal 35, right? We want the probability of X equal to 35. This is where we have to read carefully because sometimes it's going to say at least, at more. There's all kinds of words that there's going to be. Okay, so we're going to take those pieces of data and let's go ahead and go to StatCrunch on the next page. All right, so you're going to go, you don't have to bring any data in. You're going to go to Stat, Calculator, and over here to Binomial. Okay, when you do that, this graph is going to open up. It's not going to look exactly like this. And you are going to put in what you need. So our N is 100. We're going to put 100 in. That's our sample size. Our probability of success is 0.26. We're going to put that in that next box. The box inside the parentheses is a drop-down window. We're going to put equal and put 35 here. Then you're going to hit compute. When you do that, you are going to get your answer right here. So the probability of X equal 35 is going, let's do 3 decimals. So 0.012. And that is all calculated by StatCrunch. And so we don't have to use that other formula because that other formula gets really crazy if we have more than 1. If it's not just X equal to, if it's X less than or X greater than, gets very complicated and time consuming. So we're going to go ahead and let StatCrunch do the work. Okay, let's look at another problem. We have, in a survey, US adults were asked to identify which social media platforms they use. The results are shown in the figure. 6 adults who participated in the survey are randomly selected, so N is equal to 6, and asked whether they use the social media platform Facebook. Construct a binomial probability distribution for the number of adults who respond yes. All right, so N is 6. P is equal to 0.68 because we want to look at the percent who use Facebook. That's our success. Q would be 1 minus 0.68, so that gives me 0.32. And then we are going to go ahead and put a probability distribution together. So let's look on the next page. We can use StatCrunch. I'm going to show you that on the next page, but let's set up our table. So we want X in the first column, and we're going to go from 0 to 6, right? Because we talked to 6 adults. So it's possible that none of them use Facebook. 1 uses Facebook, 2 uses Facebook. And so we want to set up that table, but we're not going to do all this craziness. We are going to use StatCrunch, but we do need to know that N is equal to 6. We need to know that our probability of success P is 0.68. I think that's all we need. So let's go to the next. Okay, so we're actually going to compute this in StatCrunch 6 times. So we're going to go to Stat, calculator's binomial, we're going to put in n equals 6, p equals 0.68. For the first one, we're going to put x equals 0. We're going to hit compute, get the answer. Then you're going to hit go in and this time put 1 in the box and hit compute. Then put 2 in the box and 3 and so on. But let StatCrunch do the work, and you are going to grab the probabilities on the other side. So as soon as you hit compute, you'll get the probability out. So this is the probability that x equals 0. This one is the probability that x equals 1, and so on. And that way you can fill in that table. All right, so this would be the same thing. You're going to go ahead and use StatCrunch. You've got 62% of cancer survivors are ages 65 years or older, so P is equal to 0.62. You talked to 6 cancer survivors, so N is equal to 6. P is equal to 0.62. And then use StatCrunch to create the table of probabilities. So you're going to use stat calculator binomial and put in your information, and you will have to do StatCrunch 7 times. Put x equals 0, x equals 1, x equals 2, and all the way through x equals 6.